Hello, nice to meet you. I am Kim Namil from Messaging Data Engineering Department. The topic for this session is quickly building Kafka Stream ETL system with KSETL. KSETL stands for Kafka Stream ETL. So it's a system that extracts, transforms, and loads data on Kafka. The target stream is unbounded continuously generated data, and this includes user log or sensor data. Then why stream processing is necessary? It's because we want to process data with low latency. Low latency in data processing is a basic requirement for certain business sectors. For instance, food delivery business. The delivery status and order status must be up to date, and for financial transactions, you need low latency in order to detect fraudulent transactions. So that's why low latency is necessary, and sometimes it can improve the performance. So when recommending contents to users, if you base it on the user's up-to-date information, the performance can be much better. The stream processing method is useful because batch processing system is not enough. Conventional batch processing methods cannot sufficiently reduce processing latency because even if you reduce the unit of processing cycle to hours, minutes, or even seconds, there's still a limitation. So that's why we had to develop our own stream processing system. There are more demands for low latency, so we needed more stream processing systems. There are many common tasks in developing an operating systems. First, you need to write and debug programs and build programs, and you need to deploy programs that you build, and you also need to monitor the programs. So many data engineers do the similar works. So KSETL set a goal to make this task easier. In line, Kafka is used a lot for stream data, and KSETL makes it easy to create stream processing system using Kafka topics as input and output. So it means that the goal was to enable data engineers to create their own stream processing systems. Then, how can data engineers build their own systems? The goal of KSETL was to make it easy for data engineers to do that. So they needed to express ETL logics easily and build systems easily. So let me explain these in more detail. First is expressing ETL logic easily. For data engineers usually don't have a lot of programming expertise, but all data engineers know well about SQL. So we wanted to introduce a SQL engine for stream processing. So we wanted to use prototypes using various SQL engines, and we reviewed which one was the most suitable for us. We checked whether it included all the features we need, and it had to be also easy to use. So among KSQLDB, Flink SQL, and Spark structured streaming, we finally selected KSQLDB. KSQLDB provided most of the features that we wanted, and also it supported user-defined function. And it's a system just for stream processing, so it had a simple structure. So if necessary, we were able to analyze the source code and solve problems. And you only needed Kafka to use that. Line has very excellent Kafka support, so we also took that into consideration when we selected this. This is the internals of KSQLDB join. So when you join two streams, each partition is processed, and the internal state log is stored as an internal topic. And internal topics are dynamically created by KSQLDB as needed. And the dynamically created internal topic, when it causes a problem, and I will explain about how it became a problem later. And our second goal was to build system. We wanted the data engineers to build systems easily. So even if you express logic easily, it shouldn't be hard to make it into a system. So KSETL allows engineers to dynamically create KSQLDB clusters whenever we need them. So we call it as ODA, which is on-demand app. This ODA provided logging and monitoring as default, so data engineers just needed to run queries against the KSQLDB cluster. So this is the architecture of KSETL ODA. In a big Kubernetes cluster, we have many KSQLDB clusters. They use a common in-house Kafka. Because Line has a good infra, it was relatively easy to develop. So I received a lot of help from Kubernetes and Kafka operation team. So when query is performed in the generated KSQLDB cluster, logs are automatically collected and retrieved. And there is also a dashboard to check the situation. So the basic function was already implemented because we had the underlying system. So we were able to save a lot of effort for system development itself. This table shows the comparison between traditional and KSETL. The traditional systems uses Java or Scala, which is a common language. KSETL uses SQL, which is a language dedicated to data processing. And for building, traditional system used compile, but KSETL uses interactive shell. And for deployment, traditional system used CI/CD tools, and KSETL used on-demand cluster. And also for monitoring, the traditional system had its custom tools, but KSETL has the pre-built dashboards that we can use. So I will show you an example system that I applied KSETL to build the system. So this is a system for A/B test status report. So Line runs A/B tests before releasing new features, and it processes request logs from Line server, and it has up to 50,000 logs per second at peak time. And this includes event logs from Line client. And you also need to find client reactions for request and aggregate. And to do that, stream join and windowed aggregation are required. This looks very complicated. The previous A/B test report, you had to go through a very complicated process. I needed to find the event log and request log that have the same key. And you have to store one stream continuously in Redis and continuously read others, and I searched Redis. And at this time, you need to consider the time difference between the two streams, and you had to implement the join window by calculating the delay. You had to have Redis, and you had to treat delay logic as well. So this logic was really complicated, but this same logic was implemented by a program by a professional developer. So in KSETL, it's now a single SQL query. And this query joins the event stream and the request log stream with the same row key. So previously, you had to take a very complicated way, but now it's much simpler. Window aggregation was also very easy. So you just needed to declare the section you want to collect as a window. So for this example, we set it to aggregate in minutes and also include data delay by up to 10 minutes. This had to be developed in a very complicated development language, but now we can use SQL to handle it in a more simple way. So as the result of the migration compared to the traditional system, we didn't have to use Redis, so it became a much simple structure. So we didn't have to put efforts to use Redis. And since we developed in an interactive shell, we were able to develop and release more quickly. And there was a performance dashboard, so we can monitor and tune faster after we release. So when there's a problem, we check the logs and we were able to respond to problems quickly. However, I found some limitations of KSETL as I used it for my own work. KSETL actually is dependent on KSQLDB and the company-wide Kafka. So KSQLDB is really developed, but some features are missing. When we used UDF to implement some parts because there were some missing features that we wanted. We didn't actually consider Flink SQL at that time when we reviewed, but there are some additional features that are added, so we can review that again. And Line Kafka team is the team that supports Kafka to all liners, and they focus on stability. So they prohibit the creation of dynamic topics. However, as I explained, KSQLDB dynamically generates or creates internal topic. So we couldn't use the in-house Kafka system. So we had to solve this by creating a separate development environment. So it means that we were able to create dynamically the internal topic, and we had to create requests to create the internal topics dynamically. But we develop things slower because we had to do additional work for this, but we need a solution in order to develop more rapidly. There are some future works left for KSETL. While I was working on the project, we needed a feature that imports data from Hive table. So it's importing Hive tables to enrich Kafka topics. This feature will be frequently used, so we probably need to do some future works. And also, we need to work on enhancing query deployment. Now we deploy by executing query script on interactive shell. But if we do it manually on interactive shell, it's not good. There may be a possibility of a human error, and there are some more room for making mistakes. So I thought that it would be nice to automate this part. So today I've presented about the reason why we developed Kafka stream processing system and the goals and what I actually developed. This is the end of my presentation. Thank you.